Hi everybody. So recently we've been looking at passive transport, which deals with the diffusion of molecules from a greater concentration to a lower concentration. And that can happen within a cell, or it can happen with any molecule or atom. So for instance, just to review, right, like diffusion. So imagine we have a space here, and there are 7 atoms of, let's say, sodium introduced into that space. Initially, they're going to be highly concentrated, but because of diffusion and the natural motion of molecules and atoms, what's called Brownian motion, these particles are going to begin to spread out and fill the container, and over time, if you give it enough time, they're going to spread out so that we have an equilibrium, where the concentration of these particles is the same throughout that volume, that space that they're in, okay? The same thing happens in cells, and it affects cells in terms of their water volume. So let's consider this cell and the environment a beaker that it's placed in, okay? This cell is 3% fructose and 1% glucose. Those are monosaccharides, simple sugars, okay? What we're going to do then is assume that the rest of the cell is 96% H2O. The remainder of the cell is water, okay? Because, the total would be 100%, so 100 minus 3 minus 1, minus 3 minus 1 is 96. The environment is 2% fructose and 1% glucose, okay? So the total again would be 100. 100 minus 2 and then minus 1 is 97% water, okay? So diffusion. Molecules and atoms go from where they're more concentrated, meaning where they're at a higher percentage, and they move in the direction to where they're at a lower percentage, a lower concentration. And the only time this would stop is when the concentrations become equal, when an equilibrium is reached. And at that point, the substances would be moving back and forth with no overall change. So let's work through these questions then. Which solutes will exhibit diffusion into the cell? Meaning, of fructose and glucose, will either of these from the environment move into the cell? And again, the way you figure that out, you compare fructose, 2% to 3%, and you look at glucose, compare it, 1% to 1%. And if any of these in the environment are at a higher percentage, a higher concentration, they will move into the cell. Now, if we look at fructose, 2% is less than 3%, so fructose will not diffuse into the cell. Because if it went from the 2 to the 3, it would be going from a lesser to a greater concentration. And they don't do that, okay? With the glucose, because the percentages are equal, there's not going to be no overall movement. There'll be a little bit of movement into the cell and a little bit of movement out of the cell, but overall, no overall movement. So neither of these solutes will diffuse into the cell because they're either the same concentration or less concentrated in the environment. Question 2, which solutes will exhibit diffusion out of the cell? So again, this just means that, of fructose and glucose, the solutes which will go from the cell into the beaker, which will move overall in that direction, okay? And again, you compare the percentages. Fructose, 3%, is greater than 2%, okay? So fructose will diffuse out of the cell because it's going from a greater concentration in the cell at 3% to a lower concentration in the environment at 2%. So fructose will diffuse out of the cell. Okay. Glucose, again, will not, because it's at equal concentration. It's at an equilibrium. Okay? So again, with diffusion, things are moving from where they're more concentrated, such as 3% fructose here, to where they're less concentrated, here, 2% glucose. Okay? And the idea there is that, the natural motion causes them to spread out and eventually reach an equilibrium. Next question here, in terms of solute, we've been using these words, hyper, hypo, and isotonic. What kind of environment is the cell in? Okay? So if you look at the total solutes here, the environment has 3% of the environment are the solutes that are dissolved in the water. In the cell, we have 4% solute, okay? So the environment has a lower concentration of solute. 3 is lower than 4. So the cell is in a hypotonic environment, okay? Because the environment has a lower concentration of dissolved solutes. So now, water, in which direction will there be osmotic movement of water? So what that means is, will water leave the cell? Will water go into the cell? Or will water be at an equilibrium? Okay? And remember that osmosis is diffusion specifically of water across the cell membrane. Okay? So, water, like any other substance, will go from more concentrated, higher percentage, to a lower concentration, lower percentage. Okay? So you got to compare the numbers again. Environment, 97% water. The cell, 96% water. So the water will go from the 97 to the 96, meaning that our water will go into the cell. Okay, that's H2O there. So in this example, in this specific scenario, water will move into this cell. So number 5 then, what's going to happen? If the cell sits in the environment for several hours, what's going to happen? Volume of the beaker will increase. No, because the beaker is losing water to the cell. Okay. Volume of the cell will increase. Yes, because the cell is gaining water from the environment, its volume will increase. Volume in the beaker will decrease. Also, yes, because the beaker is losing water to the cell. So if you were to remove the cell, the volume of the beaker, its amount of water, would actually be less than what you started with, because that cell absorbed some of the water. The volume of the cell will decrease. Well, that's not right, because the cell, as we said, is gaining water from the environment. So the volume of the cell wouldn't decrease, it increases. So for number 5, you should circle B and C, okay? So hopefully that gives you a sense of passive transport and diffusion and how these things apply to living cells in their environment. If I wanted to reverse this and make water leave the cell, I could just increase this. If I made this like 8%, then water will leave the cell, okay? Or if I made it 4%, we'd be at an equilibrium, okay? All right, everybody. I hope this helps. See you next time.